In this video, we're going to be looking at converting quadratics from vertex form to standard form. If you find this video helpful, share, like, and subscribe. So, converting quadratic from vertex to standard form, or it can also be the other way around, from standard form to vertex form. Now, quadratic functions can also be written in standard form, and that's going to be f of x is equal to ax squared plus bx plus c, where the value of a cannot be equal to 0. Now, the standard form of quadratic functions can be derived by expanding the vertex form. So in our earlier studies of this quadratic, we actually use the vertex form, which is a is times x minus h square plus k. And in here, we came to know that the vertex is located at h and k of our equation. So from this lesson, we're going to now convert this vertex form into its standard form, which is f of x is equal to ax squared plus bx plus c. Now, I also would like to remind you that one of the things that you needed to perform the operations of this conversion is one of the methods in solving the quadratic functions, which is what you call your completing the square. Okay, so this is where your function is actually missing something. Okay, that's going to be b of x, and what you're going to be adding is actually the c. Okay, the c part. Now, to compute the c, we're going to get the value of our b divided by 2, and then we're gonna square that. Okay, so this is just the basic understanding that I would like you to understand when you're going to be converting from vertex form to standard form, or from standard form to vertex form of quadratics. Example number 1, what is the vertex form of y is equal to negative x squared plus 4x minus 5? So the first thing we're going to do here is to rewrite our equation, negative x squared plus 4x minus 5. Now what I'm going to do is I'm going to transfer this one on the other side, and that's going to give you y plus 5 is equal to negative x squared plus 4x. Okay, well, I'm going to now complete the square. This is still a y plus 5, but before that, I'm going to factor out the negative. Negative, it's going to be x squared, and it's going to give you minus 4x. Now I'm going to complete the square in here, the one missing in here, in order to have a perfect factor in here. So to get that one, I'm going to get the middle part, which is negative 4 divided by 2, and then square it. So in this case, it's going to be negative 4 divided by 2 is going to give you negative 2, and then you square that again, so that's going to give you 4. Now it's 4, right? It should be plus 4, but there is a there is a negative outside, so multiply it. So 4 times negative 1 is going to give you negative 4 in here, and this is going to give you negative 4 on this side also. Okay, so let's simplify the left side. That's going to give you y plus 1. While in here, still the negative is being outside. That's going to give you x minus 2 squared. Okay, so now since we're going to be asked for the vertex form, now let us rewrite the vertex form here. The vertex form is y is equal to a x minus h plus k. It's going to be on this form. So what we're going to be doing is we are just going to put or transfer this negative 1 on the other side. So that's going to give us, here's our final answer now in here. So the final answer here is now going to be y is equal to negative x minus 2 square and then minus 1. Okay, so this is going to be the vertex form of this standard form of our quadratic equation. Now, how do you know that you did a great answer in here? So use your graphing calculators or Desmos, graph them together. They should have the same. You can also use your Desmos. That's going to be an online graphing calculator. You can actually check them out, okay? Okay, number 2. What is the standard form of y is equal to 3 times x minus 1 square plus 6? So if you're going to look at this one, this format is actually not a standard, but this is actually what you call your vertex form, yeah? So we're going to now convert this vertex form into a standard form. So step 1, we're going to just simply rewrite our equation first. Plus 6. Okay, so we're going to just expand everything. This is just like x minus 1 times x minus 1. I expanded this one. And then plus 6. Then simplify. 3 times x. This is going to be your FOIL system, right? Okay, so that's going to be x squared minus x, and then minus x again, then plus 1. Okay, and then plus 6. Next, we're going to simplify the middle term. That's going to be 3 times x squared minus 2x plus 1 plus 6. Next step, we are going to distribute this one. So that's going to give you 3x squared minus 6x plus 3 and then plus 6. Now, you have two constant terms here already. You're just going to put that together. Okay, so continuing it in this side. So we're now going to have 3x squared minus 6x. 3 plus 6 is going to give you plus 9. So your final answer here, if you're going to be writing it in its standard form, is going to be y is equal to 3x squared minus 6x plus 9. Okay, so as I said earlier, use your Desmos graphing calculator for you to recheck if your vertex form, this one, and your standard form, which you have just converted, will have the same graph. So converting quadratics from vertex form to standard form, or it can also be from standard form to vertex form. So that's going to be our activity in this video. Okay, number 1, convert the following quadratics from vertex to standard form. Okay, here we're going to just proceed. So this is going to give you y is equal to negative x minus 1 times x minus 1 minus 1 here. So still negative. That's going to be x squared, okay, minus 2x, then plus 1, and then negative 1. Okay, I'm just going to distribute this negative on all each terms. That's going to give you negative x squared minus 2x minus 1, okay, and then minus 1 again in there. So our answer here is going to be negative x squared minus 2x minus 2. Okay, so this is going to be the conversion of that. Number 2, so let's proceed in here. So this is going to give you 2 times x squared minus 2x times 2 is going to be 4x, then plus 2, sorry, plus 4, then minus 3. So let's distribute everything to each term, the 2 with each term. So this is going to give you 2x squared minus 8x plus 8 minus 3. So to convert this one, your answer now in here is going to be 2x squared minus 8x and then plus 5 only. 8 minus 3 is 5. Okay, so this is going to be our answer in here. Number 3, so let's proceed here. That's gonna give you x squared plus 4x times 2 is gonna give you 8x plus 16 plus 4. Okay, so to answer that, that's gonna give you x squared plus 8x plus 20. Okay, so this is your answer. Okay, next, convert the following quadratics from standard form to vertex form. Okay, let's look at number 4. So the first thing we're going to be doing here is to transfer this one on the other side. So that's gonna give you y minus 15 is equal to x squared minus 8x, and then we're going to add something in here to complete the square. So the middle term here is going to be negative 8 divided by 2, and we're going to square it. So negative 8 divided by 2 is going to give you negative 4, and then square it, that's going to give you 16. So 16 here, and then plus 16 also on the other side. Okay. So y minus 15 plus 16 is going to give you y plus 1. Here, let's now put it in its factor form. That's going to be x minus 4. Okay, so let's transfer again this on the other side to have our perfect form in here. So our final answer here now is going to be x minus 4 squared minus 1. So this is the answer to this question in here. Number 5. Okay, let's convert this to its vertex form. Y is equal to x squared minus 4x. This is quite easy because what all we do is we're just going to complete the square. Okay, and then plus, let's put a box in there. Our middle term is negative 4. Negative 4 divided by 2, and then we're going to square that. That's going to give you negative 2, and then square it again. So it's going to give you 4. So this is just going to give you 4. Okay, so as easy as that, that's going to give you x minus 2 squared. Okay, so this is your answer in here. Number 6. Okay, like the way we did earlier, we're going to put this on the other side. This is going to give you y minus 18 is equal to x squared plus 8x, and then plus, we're going to put a box in there. Now let's get our middle term. That's going to be 8 divided by 2, then square it. So 8 divided by 2 is 4, 4 square, and 4 square is 16. So we're going to add 16 on this side and also 16 on the other side. Okay, so that's going to give us y minus 16 plus 18 is going to give you y minus 2 is equal to, let's factor this one out already. That's going to be x plus 4 squared. Last thing we're going to do is to transfer again this one, or transpose it on the other side. That's going to be y is equal to x plus 4 squared plus 2. So this is your converted vertex form from this equation. Okay, number 7, we're going to do the same thing again. So that's going to give you y minus 3 is equal to x squared plus 4x, and then plus, I'll blank in there. My middle term here is going to be 4 divided by 2, then square it. So 4 divided by 2 is 2, and then square it, it's going to give you 4. So this is going to be 4 plus 4. Okay, so y minus 3 plus 4 is going to give you y plus 1. Here, we're going to factor this out already. X plus 2. Finally, we're going to transfer or transpose this on the other side. That's gonna give you x plus 2 square minus 1. Okay, so it's as easy as that. Number 8. Y is equal to x squared minus 2x plus 5. Same procedure. Y minus 5 is equal to x squared minus 2x plus 1 box in there and then plus 1 blank in here. So let's see, middle term is going to be negative 2 divided by 2, and then we're going to square that. That's going to give you negative 1. Square is going to give you 1 only. So plus 1 plus 1. So this is going to give us y minus 5 plus 1 is going to give you y minus 4. It's going to give you this. Let's factor this one out already. X minus 1 square. Okay, transpose negative 4 on the other side. So that's going to give you a final answer of, okay, y is equal to x minus 1 square plus 4. This is your answer. Okay, number 9. Okay, y is equal to x squared minus 8x plus 17. The same procedure. We're going to put this on the other side. Y minus 17 is equal to x squared minus 8x plus, I'm going to leave a blank in there, and I'm going to leave 1 blank in here as well. Okay, my middle term in here is negative 8. Okay, negative 8 divided by 2 and then square that. That's going to give you negative 4 square, and negative 4 square is going to give you 16. So this is going to be plus 16, and this is going to be plus 16. Therefore, simplifying the left side, it's going to give you y minus 1 is equal to this one. I'm going to factor this out one now. X minus 4. Finally, transposing negative 1 on the other side, that's going to give you x minus 4 square plus 1. Okay, so this is your answer. Convert the following quadratics from standard form to vertex form, then graph. Okay, so number 10, vertex form. So this is gonna give me y minus 7 is equal to x squared minus 6x plus, okay, I'm gonna just get this one, negative 6 divided by 2 is gonna give me negative 6 divided by 2, and then square that is gonna give me negative 3 squared. That's gonna give me 9. So this is going to give me also plus 9 on the other side. Therefore, this is going to give me y minus 7 plus 9 is going to give you y plus 2 is equal to, the factored form here is x minus 3. Then finally, we're going to transpose the 2 on the other side. That's going to give you x minus 3 square minus 2. Now, let's get the vertex. The vertex is going to be at this one and this one. That's going to be your h and k. So this is going to give you 3, negative 2. Now let's graph it. Our 3, negative 2 is located where? Which quadrant? It's going to be on quadrant, this one, quadrant 4. So 1, 2, and 3. This is my 3. And this is going to be my negative 2. So it's going to be here. So here, let's add some more. Our axis of symmetry is going to be x is equal to 3. Okay. So let's put a different color here. So it's going to be here. So the value of my a is actually positive, greater than 0. So this is going to be my axis of symmetry, this one. Axis of symmetry located at x is equal to 3. Now, I don't know where to go, so I'm going to get one more value, and I'm going to evaluate it with this y. So let's see. In this case, I'm going to get, maybe this is 3, this is 4. I'm going to get 4. X is equal to 4. So y of 4, that's going to give you 4 minus 3 square minus 2. 4 minus 3 is 1. 1 square is 1. 1 minus 2 is going to give you negative 1. So my coordinates is going to be 4, and -1. Okay, so where's my 4, -1? 4, -1 is located here. Okay, so now I can now start creating my parabola. Okay, and remember that this axis of symmetry is going to cut the parabola into 2 equal parts. So from here to here, that's only 1 unit. So from the AOS going to the next, I'm just going to count 1 unit in order to get my other point on the next. So this is how my graph looks like. Okay, so this is how your graph look like. Okay, number 11. Okay, same procedure. We're going to transform this standard form into its vertex form. Y minus 5 is equal to x squared plus 6x. If I'm gonna complete that, 6 divided by 2 is 3, and 3 squared is 9. So it's gonna be plus 9. So on this left side, you're going to have y minus 5 plus 9. It's gonna give you y plus 4. And if I'm going to factor this out, it's gonna be x plus 3. Okay, getting then positive 4 on the other side, that's gonna give me x minus 3 squared minus 4. So my vertex is located at 3, -4. Okay, my axis of symmetry is x is equal to 3. Okay, I need one more point, so maybe I'm going to get the value of x. So let's say y of, since my axis of symmetry is 3, I'm going to get one more number on its right side, and that's gonna be 4. So it's gonna be 4. It's gonna be 4 minus 3 squared minus 4. 4 minus 3 is 1 squared minus 4. It's gonna give you -3. So my coordinates in here is gonna be 4, -3. Okay, so let's plot first our vertex. Our vertex is -3, 4, this one. Okay, that's going to be 3, -4, 3, -4, 1, 2, 3, and then -4, 1, 2, 3, and 4. So they're gonna be meeting here. This is my vertex, and my axis of symmetry is on the same x value, which is 3. Okay, so here I'm just going to put a red line in there. Okay, and then I evaluated earlier with one more point, which is 4. So if I'm going to get my 4 is gonna give me -3. So remember, this is 3 already, and my 4 is down here, then I need -3. So this is -3. That's the -3 in there. Okay. -3 is here. This is your -3. Okay, and this is your 4. Okay, so my next point is going to be at 4, -3, and I'm going to reflect that on the other side, which is this one unit only. So if I'm going to draw my parabola, it's gonna be going this way. Okay, so that's how you're going to answer these kinds of questions. Okay, let's do one more maybe, or one or two more, and then we're going to proceed with the next part. Number 12, -x squared plus 4x minus 1. Okay, so the same procedure, we're going to say y plus 1 here is gonna give you -x squared plus 4x. Now next thing, before I'm gonna complete the square, I'm going to factor out my negative outside. So that's gonna be x squared minus 4x. Okay, and then I'm gonna leave blank in there. So now my value of BE here is -4. -4 divided by 2, and then square that. -2 squared is gonna give you 4. Now you have 4, but you have to multiply it with the negative outside. So 4 times -1 is gonna give you -4, and on the other side is also -4. Okay, so y plus 1 minus 4 is gonna give you y minus 3. Here we can now complete this x minus 2 square. Okay, completing the procedure, that's going to give you negative x minus 2 square plus 3. So the vertex is located at 2, 3. Axis of symmetry is 2. Now my axis of symmetry is 2, so I'm going to evaluate the function when it's going to be 3. Okay, so if it is going to be 3, or maybe let's say 4, I'm going to say 4. So that's going to be negative times 4 minus 2 square plus 3. It's going to give you negative 4 minus 2 is 2 square plus 3. That's going to give you negative 4 plus 3. And negative 4 plus 3 is just going to give you negative 1. So my coordinates here is going to be 4, negative 1. Okay, now I have all the information I needed. First, my vertex is at 2, 3. That's going to be 1 and 2. This is my 2. And 3. This is my 3. So they're gonna meet here. Since it is negative, there's a negative in front. It means that that's gonna be opening downward. Okay, I evaluated 4. If my value is 4 here, 2, 3, and 4, then I'm gonna go down to negative 1. So this is gonna be my next coordinate in here. Okay, remember that our axis of symmetry is on this value of x equal to 2. That's our axis of symmetry. Now, this point that I created in here for negative 1 is a guide for me where will I connect my vertex to the next point. And also, with that point, I can also now reflect on the other side of my parabola, because in here, I also don't know, on the left side, I don't know where to go. But on the right side, from the right side, on this point of 4, negative 1, there are 2 units when you're going to reach the axis of symmetry. So from the axis of symmetry, I'm going to count also 2 units, 1 and 2, and that's going to be my next coordinate in there. Okay, so drawing now the graph is just going to be going that way. It's not accurate, but at least you see what we are doing here. Okay, so this is now your graph. Okay, number 13. The same problem. It has a negative on in front. It means that this is going to be opening downward. Okay, let's continue. Y plus 7 is equal to negative x squared minus 6x. Okay, y plus 7 is equal, I'm going to factor out the negative, so that's going to give you x squared, then plus 6x, and then I'm going to just leave a blank in here. So my middle term here is 6. 6 divided by 2, and then square it, that's going to give you 3. 3 squared is equal to 9. But since I have a negative outside, I need to multiply that by negative, so this will become negative 9, and on the other side is also negative 9. Okay, so y plus 7 minus 9 is going to give you y minus 2. Here is going to be negative x squared. Okay, let's just simplify this one. X plus 3 squared. Okay, y is equal to negative x plus 3 squared plus 2. So the vertex is located at negative 3 and then 2. Okay, let me just get more. My axis of symmetry is negative 3. So maybe I'm going to get negative 5. Okay, what will happen if I'm going to get the point negative 5? Okay, so that's going to give you negative times negative 5 plus 3 squared plus 2. Negative 5 plus 3 is going to give you again negative 2 squared plus 2. Here negative times 2 squared, negative 2 squared is 4 plus 2. And this is going to give you minus 4 plus 2 is going to give you minus 2. So my coordinates here will be negative 5 and negative 2. Okay, I have all the information needed. So first I'm going to put my vertex. This is our vertex, okay, and this is our additional point. Okay, so where's my 3, -2? -3, 2 here. 1, 2, 3. This is our -3, and 2 is here. So this is the meeting, that's the vertex. Now remember that there's a negative in front, so it's gonna be opening downward. Then my next point is at -5, -2. Okay, 3, 4, 5, and then it goes -2. So my next point is gonna be here. So my axis of symmetry is actually at x equals -3, this one. Okay, that's my axis of symmetry. It means to say I can just mirror on the other side. So 2 units from this point to the axis of symmetry, therefore 2 points also from axis of symmetry to the next, to the right side of the parabola. Okay, now I have already the points. I will just connect them, and that's it. Oops. Okay, and then it's gonna go this way. Okay, so this is how you're going to answer these kinds of questions. Okay, so this is all for these lessons on converting quadratics from vertex form to standard form. If you find this video helpful, share, like, and subscribe. Thank you very much.